papers. Here's another PowerPoint, which basically just said we just need atomic rights to simulate block I/O for backwards compatibility. So if you have a bunch of data and you're writing a block, or if you crash right between it, your storage is in an inconsistent state. So you need have atomic block rights. That's pretty much what this PowerPoint said. Ooh. NEMOC is a system made by University of Wisconsin, which are really big players in this NVRAM OS research. They're in direct, they're working with HP Labs directly in this type of subject, so they're kind of ahead of this area. But NEMOC is practically a system where they added some C constructs into a C compiler, so they just extended GCC, and also added a subsystem in the OS kernel to handle to know which programs are persistent, which variables are supposed to be persistent, and where they are. So this type of system assumes that the NVRAM and your volatile RAM are on the same shared memory space. And they added some C constructs like pstatic, so you can store a variable onto the persistent memory. You can have pmalloc to allocate memory on the persistent memory. And as the paper before, or the slide before, we need to write atomically to keep your data structures within your persistent memory consistent. So that's what this is what they did. But the biggest problem they had with this system is that programs can't really share files because their address space is kind of is just their own. The processes is just their own address space. So they made another system called ARI, which I'll talk about after the next one. So here's another file system, and some people from Korea, I forgot what school they were, but they pretty much made a byte addressable file system, which they believe that they put the file system, they believe it should be in user space instead of kernel space, because if you're putting it in kernel space, you're going to need to do some system calls. And the only reason you need to do system calls is do interrupts. And when you do interrupts and traps, you're contacting like an external device. Well, NVRAM is memory. You don't need system calls. So just put it into user space. So there's no need for traps, interrupts. So that makes your code a lot faster and more CPU bound faster. And with this type of system, they can use memory optimization techniques. So they can, if you have a certain interface, you can batch your IOs request to your storage class memory, or you can do zero copy. So you don't need to copy data from kernel memory to user space memory. You can just change the reference variable. And there's a swapping queues. And the way they did this is by adding this extra layer called the hardware abstraction layer. And so by doing that, making the underlying layer under all the block I/O that you have in your Linux system. So current programs can interact with the file system how it's always been, and just interact with the hardware abstraction layer. But if you're making new programs, you can just access it directly with its interface. So I think that was pretty cool. Here's another system. It's going to be the last system I'm going to be talking about. It's called ARI. And they made 3 changes to the operating system. They believe that file system should just be a library, and you can connect it to make the app link to the library file system. So you can, by doing this, you can have different file systems to your program's need. So sequential file system, a random access file system, big, small files, whatever fits your needs for your app. And there's this storage class and memory manager, which is pretty much your virtual address manager and protection layer. But this TFS is called a trusted file system service. What this does is, because the library file systems are linked with the apps, how do you know if another program is being malicious and using a malicious library file system? Well, you got to make it so the library file system interacts with this trusted file system service. So the program itself can't do malicious things like putting the same name of a file in the same directory. So that'd be bad. So that's what this is used for. So, like I said, they believe the library file system should be on user space because there's no need for system calls. You have direct access to data, and you can have a specialized file system for what your program needs. The SCM manager handles the allocation to memory, and it does protection of files, and it builds the page tables of your program, so it still has the virtual addressing, and it also assigns your virtual addresses. So it's pretty much your replacement of your virtual address machine or service. And as I said before, the trusted file system service coordinates metadata. So if you do updates to some directories, it has to go through the trusted file system service. It handles locks, so you have exclusive right to a certain file. That's what the trusted file system service does. And it does this by doing a lease manager. It's kind of the same method used in distributed operating systems. So the TFS gives a lease to the app that you have exclusive right to this file. And if I want it back, I'll tell you. So if I ask for the lock back from the app, and if the app doesn't give it back, it just ignores all updates that the app tries to do, and that's how protection from malicious code can happen. And yeah, and also you can have, it does this by, each app has a log of all the updates it wants to do, and just sends that one transaction all those transactions into a log file and gives it to the trusted file system service, and it does that all in one go. So that's the efficiency of the service. So that's how there's not really a bottleneck into the trusted file system service of the program. So in conclusion, there's many NVRAM implementations, and there's many NVRAM OS design problems. And if we want to use the NVRAM devices in our computer systems, are we going to be doing revolutionary style or evolutionary style? So that concludes my presentation. Is there any questions I can answer? I know it's pretty dense, but I hope you guys got the gist of it. All right, thank you.